Welcome to our new topic, the Newton's laws of motion. In our previous topic, we tackled kinematics, where kinematics deals purely with description of motion. So meaning description, like how fast the body is moving. It refers to its speed, the rate of the change of motion, or this refers to acceleration. So meaning in kinematics, there is no inquiry as to why the motion of the object changes. So what causes the change? So in this Newton's laws, we are now under dynamics, where dynamics deals with the factors responsible for generating motion of the bodies, why the object or bodies move, and the general effect of these factors. So we are under dynamics study, where dynamics is one of the branches of mechanics. So in dealing with the factors affecting the motion, or what causes the motion, Newton developed a very precise and powerful theory regarding motion in his famous Newton's three laws of motion. The first law states that a body at rest remains at rest, and a body in motion continues to move with constant speed in straight line unless acted upon by a net external force. This statement, we can classify or identify two situations. Example, the first situation, a body at rest remains at rest. So meaning, if your V naught or initial velocity is 0, then after some time, your final velocity is still equal to 0. So meaning it remains at rest. And then for case B, a body in motion, so the V naught or initial velocity is not equal to 0. But then after some time, the final velocity is equal to its initial velocity because constant speed. And since velocity is constant, it must have the same direction. So direction also is not changing. So therefore, velocity is constant. So both cases, the velocity is constant since in our case A, the speed is constantly 0 also. But then this cases A and B, or situations A and B, can only be true or satisfied. It will happen only if this condition is met. If the net force or the net external force is 0. So what is an external force? Okay, let me illustrate a situation for you to identify what is an external force. Sample, so if it is our body with mass m, the external force are the forces acting on the body. Sample, the force of gravity and the force exerted by the surface, if it is, sample, if this is our F1, F2, these are the external forces, or this one, F3 in this direction, and also another force, F4. These are the forces acting on the body, labeled as external forces. So meaning, if you're going to sum all of these forces acting on our mass m, then the summation should be equal to 0. The if net, or the net external forces, we can also call this one as if net, and this is equal to 0. So in this case, if we are to sum all the forces acting vertically, so this is summation of all the forces acting on the body along y, then this must be equal to 0 to satisfy cases or situations A and B. So therefore, if in this case F2 is positive, meaning the force exerted on the body is upward, and then plus F1, but take note our F1 is directed downward, so it's negative. F1. This should be equal to 0. It means that F2 is just equal to F1. Therefore, the sum of the forces acting along vertical is 0. If the summation of forces along X or along horizontal is equal to 0, then there's no motion also along horizontal if the body is initially at rest. So, in this case, your F3 plus the negative F4, why negative? Because F4 is directed towards left, taking the right direction to be positive. So the left direction is labeled as negative. So this is equal to 0. Then F3 therefore is equal to F4. Meaning, the situation in here, the forces acting horizontally balance each other. So if balance, then the mass is at rest along horizontal, it will continue to stay at rest. If it is moving, it will continue to move with constant velocity, meaning the same magnitude and in straight line. So in short, the first law states that body would continue to stay at rest or preserve its state of being at rest, or it will continue its state of motion if there is no unbalanced external force acting on that body. Our first law is just the principle of inertia. Inertia, or law of inertia, states that the property of the body which measures its resistance to its change of rest or in constant motion. This is just another way of stating the first law. Because in the first law, if the body is at rest, it would continue to stay at rest. But if it is in motion, it will continue to move constantly. Therefore, it's just the resistance to its state of rest or being at rest or in constant motion. And the measure of inertia is its mass. Meaning, the greater the mass, the greater its tendency to resist the change of its state. So it is difficult to stop a very huge moving mass because of its resistance to a sudden change. Let's have a sample situation. Consider a man standing on the floor inside a bus. So if the bus initially at rest, then suddenly moves towards this direction, the tendency of the person is to be thrown in the opposite direction. Why? Is there any force that push the person to move in that direction? I don't think so. So what's the explanation? The bus moves in that direction, but the tendency of this person is to stay at rest with respect to the ground. So in the case where the bus is moving constantly, so no matter what is the magnitude or even how fast the bus is moving, the person inside the bus need not to hold on to anything inside the bus to keep abreast with the motion of the bus because of its tendency to keep its motion along with the bus. Then in the case where the bus suddenly stops its motion, then what will happen? So meaning from constant motion and then it will decelerate to stop. So what will happen to the person? The tendency of the person is to move forward. Why? The person will keep its state of being in motion with respect to the ground. So this is the resistance to a sudden change, and this is inertia. Therefore, when we see an object slowing down or speeding up or changing in direction, so this is the case of accelerated motion. Therefore, there is already an unbalanced external force acting on the body. So if net is not anymore equal to 0. So this is our topic for the next session. The second law, Newton's second law of motion.